Today's video deals with what's called percent composition, or sometimes we just call it percent by mass. Many times when you have a chemical formula, you can use a device, you can put that chemical formula into a device and it will tell you what percent of that compound is made up of hydrogen or what percent is made up of oxygen or carbon, etc. And what that machine does is it basically does what's called this percent by mass for you. And so you can analyze a chemical substance, an unknown chemical substance, by looking at what percent of each element is in that compound. So when you calculate the percent by mass or the percent composition, again, same thing. Percent composition is the percent by mass. It's, again, the percentage of that element in the whole compound. And to get a percentage, you do multiply by 100. Okay, so in this first example here, it says, what is the percent composition of hydrogen in H2O2, hydrogen peroxide? So in order to figure out the percent composition of hydrogen, we're going to take just the mass of hydrogen, and then we're going to divide it by the mass of the whole compound of the whole H2O2. So notice we're going to put the mass of the hydrogen on the top. We're going to put the mass of the whole molecule on the bottom, and then we'll multiply by 100. So we go to the periodic table, we look at the mass of hydrogen. Hydrogen has a mass of 1.0, and in H2O2 there are two of them. So we multiply that by 2, so that's where we came up with this number 2 on the top here. I didn't put 2.0 just because I'm lazy. Okay, okay, and then we put the mass of the whole molecule on the bottom. So again, the mass of hydrogen plus the mass of oxygen, which is 16, times 2 equals 34. So the total mass of the compound is 34 grams per mole. So we've got the mass of the hydrogen on the top, 2 grams per mole, over the total mass of the compound, 34 grams per mole. We divide those two numbers, we multiply by 100, and you get about 5.88% of that whole molecule is hydrogen. So when they say things like, your body is made up of 42% oxygen, what that really means is all of the molecules that are in your body, there's a lot of oxygen in them, because really a big part of that is water. Most of your body is made up of water. And so when they say that your body is made up of X amount of oxygen and X amount of hydrogen, basically they're doing this exact same thing, as they're taking percentages from the compounds that are in there. Obviously, our bodies are not filled with a bunch of air, a bunch of O2, right? But there's water in, or there's oxygen in water, there's oxygen in sugars, there's oxygen in fats. So there's oxygen in lots and lots of different things. So now, using the same compound, H2O2, instead of saying, what's the percent by mass of hydrogen, we can say, what's the percent by mass of oxygen? So very similarly, we take the mass of oxygen, which remember was 16 times 2, which is 32. We still divide it by the total mass, which is still 34. We multiply by 100, and we get 94.12%. And notice that this compound is made up of two different elements, hydrogen and oxygen. And those two obviously have to make up the whole mass of that molecule. So if you take those 5.88% and the 94.12 and add them together, if you've done it correctly, all of those percentages will add up to 100% when you're all done. Okay, let's look at a couple more examples. So example number 3 says, calculate the percent by mass of oxygen in H3PO4. So again, the mass of oxygen is 16, and there's 4 of them. So that's 64 grams per mole. The mass of the whole thing is hydrogen's 1, and there's 3 of them. Phosphorus is 31, and again, oxygen, 16.0 times 4 equals 98 grams per mole. So the mass of oxygen is, again, 64. The mass of the whole thing is 98.0. And then we're just going to multiply by 100 to get to a percent. So now I go to my calculator, 64 divided by 98 times 100 equals 65.3%. Okay, and that is the percent by mass of oxygen. Now, if they said, and we could do this really quickly, what's the percent by mass of hydrogen in the same thing? Well, we just quickly change that oxygen on the top to now we're going to put the mass of, remember right here, hydrogen. And then 3 divided by 98 equals times 100, let's say 3.1% hydrogen. So this was oxygen. And then we could do the same thing for phosphorus if we wanted to. Again, they're not asking us to. We're just trying to look at some different examples here. 31.0 divided by 98 times 100 equals 31.6% phosphorus. And again, like always, now that we've done all of the different atoms within that molecule, now we can add them together and we will get 100%. Now, sometimes due to rounding, it might be like 99.9 or maybe 100.1, but it's going to be really, really close to 100%. Okay, example number 4, kind of going backwards here. They're giving you a few different compounds, and they want to know which of the following molecules has a mass percent. Again, same thing as percent by mass, same thing as percent composition. They're saying the same thing, just different ways. So has a mass percent of oxygen equal to 48%. So here's where right away I'm just going to go to my calculator. I'm just going to start with the first one. And oxygen, again, they want the mass percent of oxygen, so it's going to be 16 on the top. And now I'm going to look at my periodic table here that has a mass of chromium is 52. So 52, again, I need the total mass on the bottom. So 52 plus 16 is 68. Times that by 100. 16 divided by 68 times 100 is 23.5%. Okay, is that 48%? No. So, of course, it's not CRO. Okay, and again, there's no real way to do this other than just guessing and checking. Okay, so now we'll take the second one. So that'll be the mass of oxygen will be 32 on that one. And then it'll be 52 plus 32 for the total mass, which is equal to 84. And then times 100. 32 divided by 84 is 38.1%. 38.1. So nope, that one's not it either. How about CrO3? CrO3, 3 oxygens has a mass of 48. And then chromium again, 52 plus 48 for the total mass is 100. Times 100, well, there those hundreds just cancel out, and there you go. There's your 48% right there. The correct answer is CrO3. So again, percent composition is a great way to figure out what percent each element is in a compound by taking the mass of that element, putting it on the top, and putting the mass of the entire compound on the bottom.